going to talk about JSON API. I'm Marco, but despite of the Italian name, I'm actually from Germany, from Munich. I founded Simple Labs. We're a engineering consultancy from Munich. We do lots of Ember.js, Rails, and recently also Phoenix. And you will also see that Ember Data actually has an important role in the history of JSON API. And I also brought some stickers from our local Munich Ember.js meetup. You probably found them in the bags already. We are also doing an Ember.js workshop in Berlin in January, so I wanted to take the chance and announce that here again. You can use the discount code if you want to come. So JSON API. What JSON API is, it's a specification for building APIs in JSON. So this talk is not like about JSON APIs in general, but about that specific specification, right? That's just called JSON API. They just took that very generic name and used it. What's funny about the logo is actually that it's missing the quote, so it's not actually valid JSON. I think Steve Klebnik, one of the core maintainers, said that's an Easter egg, and he pretty much likes it, and very funny, of course. So a specification for building APIs in JSON. So many of you might ask, why is that even needed? One very popular guy who's asking the same question is actually Thomas Fuchs, former Rails core team member and like Scriptaculous maintainer. And I think he doesn't like the idea of having a specification for JSON APIs. While I don't want to say anything against him, I mean, he did great things, but in this case, I wouldn't agree that it doesn't really make sense to have a specification for that. But of course, the reason why he is asking that questions, and probably others are as well, is that everybody's already using RESTful JSON APIs, so why do we need a spec for that? And the reason is that they are all slightly different, which makes the reuse of client code really hard. You have to rebuild the serialization and the deserialization for every project from scratch, or maybe not from scratch, but like you can't reuse the components because it's all, every time it's a bit different. And also you have to relearn the concepts of the APIs every time you start a new project, because like there's, like every API uses its own like rules for structuring documents and stuff. I have some examples to show that. So this is from the GitHub API. If you get a repository, you get the ID, name, and more attributes. You don't have a root level object, so it's like all flat in that object. If you get the same repository from Travis, then you have that root level key, and the rest is actually the same, but that's already quite a big change. Like, it means you cannot use your parser code for that, reuse your parsing code for that. Next example, that's Twitter, and of course I'm not actually user number one on Twitter, but you see it has a very like special URL, so it doesn't really follow that standard thing /user/ID, but it like uses something else. That's the same example from GitHub again, and you see here it uses the standard URL. Another thing that's almost always different is how relations are structured, and like structured in the responses and requests. So in this case, you have an embedded relation, like the owner of the repository is included with all the attributes. And that's from GitHub again. And again, the same, or not really the same example, but if you get a branch from Travis, I think that is, then you get the repository just as a foreign key, kind of, and don't get the data already. So whenever you build and use these API, or basically mostly when you build such APIs, there's a lot of discussion about what you actually want to use. Like, do you want to have a root object, or do you just want to have a flat object? Do you include relations, or do you just like specify the foreign key? And that these long-lasting discussions are called bike shedding. And bike shedding actually is a synonym for Parkinson's law of triviality, and that means that when people are like have to build projects, they would usually spend a significant amount of time on rather unimportant things. So I think that guy Parkinson, he observed that a team that was in charge of, I think, like reviewing plans for nuclear power plants, they were spending significant amount of times on discussing unimportant things, for example, the materials that should be used for the bike shed. And that's why it's called bike shedding. And probably everybody of you has gone through that already. And the point is really that for these actually not so important decision, it's not really so important which one you make, like which one you pick, like whether you want to have a root object or not, but it's just important you agree on something and use that, for example, on the client and on the server side. So the slogan, more or less, of JSON API is that it wants to be an anti-bike shedding weapon and wants you to not have to have these discussions, and so you can focus on actually implementing the system you're about to implement. I just want to give you some history, just for the background. Basically, it all started with a lengthy discussion between Yehuda Katz and Steve Klepnik at RailsConf 2013, where Yehuda, and now you see the relation to Ember Data, he wanted to have something that would make it easy for him to define which API servers would be usable with Ember Data. And of course, the way to do that would be to define a JSON API format that would be supported by Ember Data, and then as your server implements that, you would be able to connect that to your Ember Data frontend. And I think Steve Klepnik was just like doing much work in the hypermedia and API space, and that's how they got into that discussion. Then Yehuda Katz wrote the first draft. It was basically just a specification of what active model serializers and Ember Data were already doing at that time, and it also diverged quite a bit from that. So it's not really similar to that first draft anymore. The 1.0 release was on May 29th this year. Now they follow a strategy where they will always only add to the spec and never remove things. So making sure that newer versions of the spec are always backwards compatible. So they make sure that regardless of the client and server versions, you can always agree on the lowest common denominator and use that, and then you just cannot use like anything that's newer, but you can always agree on that. That's of course really important for a spec. Maintainers are now Yehuda Katz, Steve Klepnik, Dan Gebhardt, and Tyler Kellen. I think Dan and Tyler did actually most of the work in the last year or so, like getting the 1.0 release out. And JSON API defines 4 goals, like that's the last part of the theory, and then we get to the actual format. It wants to define a generic media type that works for a broad set of use cases. So it doesn't want to be like limited to a few use cases. So although it's limited to the use case where you expose and consume a set of resources via HTTP, so this is not built for building like RPC systems or so, where you just want to invoke arbitrary actions from the client on the server. So. Also, they wanted to make it similar to what existing server-side frameworks were already doing. So that, of course, makes it easier to implement for people, and that makes adoption easier, which is, of course, very important for a spec as well. Like having a broad set of clients on servers that actually implement it. Also, they wanted the format to be human readable, so it would be easy to debug and easy to see what's going on. And they wanted to make sure that implementation would be simple as well on the server and on the client side. So let's go to the actual format now. I'm not going through the whole spec because that would be very boring and also probably too much to cover in this talk. You can just read up on the website. Maybe it takes like 30 minutes or so. It's actually not so long. And also, the point of a spec is that probably none of you will ever have to actually implement it yourself, because the point is that as soon as you have a spec, then people can implement server and client libraries that implement that spec, and because they implement the spec, they are proven or guaranteed to be compatible. So the majority of people can just reuse those libraries then and never really use that spec, that format directly. Also, there's no really special features or so in the specification, so it's really just about preventing you from having these bike shedding discussions and having to figure out how you want to build the API. So the format, it actually defines its own media type, like that vendor API plus JSON, that's registered with the IANA. I'm actually not sure what that means or why that's good, but it probably is. And at the core of the format, you have resource objects. And resource objects represent individual resources. So for example, if you have a request to get an article, and of course we're using a blog post as an example because everybody uses blog posts, you have to sit down. You get that response. So at first you have that data key. You have the data key at the root of the object, and that contains the resource object. So basically the data object always contains the document's primary data. There might be more keys which contain other things, but the data key is always there. And in this case, because we are requesting just one resource, it contains just one resource object. And then you have the type and ID. Those are the two mandatory fields for a resource object. And then we have the articles attributes in the attributes key. If we request a list of articles, or like all articles with a get/articles, we get a very similar response. Like we have the data key again because it contains the document's primary data, and in that case, that's an array with two resource objects that look the same as in the previous example again. Of course, you will always have, also have relationships usually, and relationships are stored in the relationships object, which is like on the same level as the attributes, and then for each relationship contains an object under the relationship names key. And what you have in the data section there, that's called resource linkage in the spec, and it's just the type and ID, so you have all the information you need to get that linked resource. And because you have the type in there, that also allows for polymorphic relationships, of course. Because you might have an array, and then the the individual linkages might have different types. And there's also a hypermedia built into the spec, although is actually opt-in. So in the last example, we didn't really have any links or so. So you can use hypermedia, but you don't have to. So if you look at the same sample again, where we had that author relation from the article, then if you use the hypermedia approach, that same thing would look like that, where instead of data containing a resource linkage, you have that links key, and that contains the links. So in that case, self would return the relationship itself. So, for example, if you would send a delete to that URL, then it would just delete the relationship. So, meaning, like leaving the article without an author, although those resources would still exist. And the related link would actually return the relationship's data. So that's pretty clearly separated, which is a good thing, of course. And you could also have resource linkage in there. So at the same level as the links, you could also have the data, and then the client would be like free in which one it uses. There's also a mechanism to include related resources. So you can reduce your request. So you might think of an example where in Rails you would have that n+1 query problem, where you get the article, and then for each article you get the author, and that scenario would actually be the same in the world of APIs. But instead of making database queries, you would make network requests. And in order to prevent that, you can just include the related resource. So this is the same example as before, basically. We have the article with the author and the resource linkage. But in this example, we have a second key on the root level, which is included, and that includes the resource objects that are linked from the main resource object of that response. So you see, this is basically a resource object again, and you could even have. So, for example, if this resource had a relation to something else, again, you could include that as well. And then basically you would have a relationships key here, some relation pointing somewhere with linkage, and then you would have another resource object in that included array that represents that resource that's related from that people resource. Then it also defines rules for CRUD, like for the routing, and that is pretty much what you expect. So nothing special there. You have to get all, get single. You have to create resource, update resources done via patch, and then deletion. And the requests look more or less the same as the responses we saw earlier. Just in the request for resource creation, you can leave out the ID. Like that's the only case where the spec allows a resource object with no ID being set, because that's usually assigned by the server. Although the client the spec also allows for client-side generated IDs, although that's probably something that just very few people use. The response is just the resource object for the created resource again, and that's really the same response you would get if you get that article. If you did get /article/1, you would get the same response. And you see it, like, of course, now it includes the ID. Then updating works the same way again. You just send that resource object via patch, and then usually the server would return 2 or 4 no content, unless the resource object that was sent in the request does not fully reflect the resource's state anymore. That might be the case if, for example, the server updates a last modified add attribute on the resource. In that case, you would get a 200 response with the resource and the response body. So you would basically get this just with that additional like last modified add attribute or so. Deletion is just regular delete request, and I think it always has to return 2 or 4, or it might actually return 2 or 2, which means accepted, I think, and that indicates that it accepted the request, but has not really performed the operation yet. So that might be the case if your deletion is delayed for some reason because it's running in a background job or so. It also has some advanced features. One of them being that you can, or that the client can request which related resources should be included in the response. So for example, you could do this, and in that example it would include the comments and the comments authors in the response and that included key. It defines sparse field sets so that you can reduce your response side in case you're reading a large number of resources. So for example, in this case, it would, for the article itself, it would just respond with the title and body, and for the article's author, it would just respond with a name. It also defines bulk operations. Those are not actually part of the core spec. Those are an extension, and the spec also defines a mechanism for extension negotiation where client and server can figure out which one supports which extensions and then like decide what they are going to use or not. In this case, we are creating multiple articles at the same time, so it's basically the same request body that we had earlier, where we just created a single article resource, but in this case, the data is an array of 2 resource objects, and then the response is basically the same again, with the IDs included for the 2 resource objects. There's a couple of Ruby implementations. I'm focusing on the client, on the server implementations here, because that's probably what's most relevant for most of you. Active Model Serializers does not yet actually support the 1.0 spec. I think it's going to support it in 0.10. Then there is ROAR. I'm not 100% sure which version of the spec that supports. There's JSON API resources that's maintained by Dan Gebhardt, one of the core team members for the spec. And there's also lots of client libraries for most relevant languages, I guess, and also like more server libraries, of course. So to wrap up, like you should really use it. Like I really like it. It saves you a lot of time, saves you a lot of fighting, both with your clients and the inside of your team. And we love it. We use it all the time. And that's actually it already.